Hello and welcome to this HSB webinar talking about Hydrogen Solutions. My name is Matthew and I'll be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the speaker bio window with background information on today's presenter. And just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. And now I would like to introduce today's presenter. With us today, we have Paul Coco, the Senior Engineer for HSB Global Inspection and Engineering Services. To read more about Paul, please look at the speaker bio window right next to the main presentation window. And Paul, welcome to today's event. And with that, I will pass things along to you to get started.
Great. Thanks, everybody, for attending. As stated, my name is Paul Coco. I'm a Senior Engineer with Hartford Steam Boiler. I work in a specialized group, and let me get my bio up there. Specialized group within Codes and Standards for Global Inspection and Engineering Services. With that, I specialize predominantly in ASME Code Section 3 and also associated nuclear and conformity assessment programs. I also deal with the emerging technology such as robotic and remote inspections, and then also with emerging renewable energy technologies such as hydrogen. Quick background, prior U.S. Navy nuclear officer. Upon leaving the Navy, I worked at the U.S. Nuclear Regulatory Commission, and I came to work for HSB, and I've been here for almost 10 years now. So a little high-level overview of today, what we're going to go over. We're going to talk about some of the engineering services that HSB can provide in the realm of supporting the emerging hydrogen industry. HSB is the largest authorized inspection agency accredited by the American Society of Mechanical Engineers and offers a wide range of inspection services for owners, fabricators, boilers, pressure vessel equipment, nuclear components, processes, and power plants. We've been around since 1866. We were originally developed the Hartford Standards, which evolved into the ASME Boiler Pressure Vessel Code in Section 1 back in 1914. So we've been had some aspect within code since the beginning. We have a long-standing reputation and a trusted provider of inspection services, extensive experience in pressure vessels and piping that go far beyond not only ASME, but other codes internationally as well. We do have global coverage. We're not only within the US, we have offices all around the world, and we do work on every single continent. We don't have offices in Africa, but we have worked in various different locations there, whether they're nuclear or non-nuclear projects. Again, we have over 400 commissioned inspectors available, and we don't work independently. We work together as a group. So if you have a project that might start off in Europe and might have to go to Asia or the United States, we have great coordination and great relationships within all our staff and personnel. So what to expect here? So this webinar is going to give you a review of the suite of hydrogen solutions HSB has to offer to fulfill your inspection needs for every stage of the hydrogen life cycle. When we address the hydrogen economy, the development of global hydrogen economy necessitates substantial need for investment in infrastructure. Infrastructure includes production facilities, storage facilities, or distribution networks. Analysts say by 2030, the hydrogen economy is expected to experience significant growth, with the adoption of hydrogen is expected to be in transportation, power generation, and various different other industries. And this growth also represents some opportunities and challenges that need to be addressed, which I'll be covering in this slide. When we do look at infrastructure investment to support the growth, again, there is going to need that substantial investment, and we'll talk about where some of that investment is coming from. For production facilities, we do look at, we see a lot of plants now that are looking to electrolysis, which we will talk about a little bit more in detail. And then you also have steam reforming technologies, which is currently the norm on how we currently produce hydrogen, and other production methods that are necessary to scale up hydrogen production. Storage also provides another issue that we are looking to address within this presentation, whether you're looking at a compressed gas, liquid hydrogen, or solid state needs. Those will have to be developed further on. And then also distribution networks. And distribution networks, whether you're looking at pipeline, transportation vessels, or refueling stations, which will all be essential in enabling the widespread distribution of hydrogen. So as we dive into the main focus, we're going to learn how HSB can ensure compliance with contractual conditions, specifications, applications, international codes, and standards. Discover how the inspection test plans and third-party inspections can support conformity assessments. Consider how to develop quality assurance through HSB ISO certification of a company's quality management system. And we'll also explore the merits of vendor qualification and surveillance and risk mitigation design and principles and services for improving quality and reducing risk throughout the supply chain. So building the hydrogen economy. So where's the money coming from? In the United States, back in November 2021, Congress passed a bill for the Investment in Jobs Act, which appropriated approximately $62 billion US for the DOE and $9.5 billion for clean hydrogen. And then further, we had the Hydrogen Inflation Reduction Act, or the Inflation Reduction Act, which also provided tax credits as well. Strategically, we're looking at opportunities of about 10 million metric tons of clean hydrogen annually. So that's on top of what we currently have already. It's going to be 20 million or 20 metric tons by 2040, and then 50 by 2050. So this next slide kind of tells you what we're looking at and where we're seeing most of this growth and development proceed. So the big buzzword now is going carbon neutral or zeroing out any type of carbon emissions that we have. And hydrogen is looking to be a way to do that. And the specific markets that are being addressed right now are within the industry sector, heavy duty transportation, and long-term energy storage to enable for clean grids. Long-term applications and opportunities might be potential, the potential of exporting clean hydrogen or hydrogen carriers to develop energy security for our allies. And as you can see from, in the last year or so, energy independence is very important. This current graphic was taken for the Department of Energy. I believe its numbers might be slightly different, but you can see the main producers or the main users of hydrogen are currently stated right here within the petroleum and recovery and refinery, and then ammonia production. And annually, we're looking at about 65 million metric tons that are produced. So the clean hydrogen that will have to be produced to facilitate the hydrogen economy, it will have to be on top of what we already have. The existing infrastructure is looking also to convert to either green hydrogen or blue hydrogen, depending on what processes they have there. Some of the biggest uses of hydrogen, other than the fact that it's part of everyone's favorite drink, it creates 2/3 of water, H2O, for all you non-chemistry types. We have hydrogen that's been around for quite some time and has provided a lot of revolutionary leaps and progresses for the development of our society as a whole. So hydrogen is used for fertilizer production, in which you can go ahead and have scaled use for synthesizing ammonia, which was done in the early 1900s, which you can see it's still predominantly used for that. Once we had mass production of fertilizers, we also had an increase in agricultural productivity, which we were able to do farming on an industrial scale. Food processing is another widespread use of hydrogen, where you have hydrogeneration, which is a chemical process involved to add hydrogen to unsaturated fats and oils to convert them into more stable and solid forms. And this will increase the shelf life of products that you would have on your food. And then also, as we talk about clean hydrogen to replace fossil fuels, within the petroleum industry, hydrogen was used starting in the late 70s, early 80s to further refine hydrocarbons, and instead of making them as a heavy form of hydrocarbons where they have more pollutants, a lesser form, and it's you were able to desulfurize and denitrify other elements and impurities removed from petroleum products as we see today. So hydrogen has played a pivotal role in essentially improving society as it is, and its next step now is looking to facilitate the revolution to going carbon neutral within the next few years. So the Department of Energy launched a campaign, which is the Earth Energy Shot, which we're looking at back in June 2021. And this looks to have the price of hydrogen at 80% to be at $1 per 1 kilogram in 1 decade. This provides multiple different targets that we can look at in order to facilitate the industry. So we look at the cost reduction, where the DOE aims to reduce the cost of clean hydrogen production by 80%, the target to achieve $1 1 kilogram of hydrogen, which makes it affordable and competitive to other energy options. If I were to go ahead and look at what the price of hydrogen today is, I would say that between 50 cents to $2 would be your steam method reform hydrogen, which would be more or less your gray category without any carbon capture. Hydrogen through electrolysis, depending on what geographic region you're at, is now currently under $5, and these numbers are commodities, so they do fluctuate. So we're almost there, but we need to go ahead and look at scaling up for the production on how we can go ahead and do that. Within scaling up, we do look at initiatives, again, to facilitate the infrastructure for production, storage, and transport, and the use of clean hydrogen across various sectors, including transportation, industry, and power generation. And it's going to involve an increase of deployment of hydrogen infrastructure and technologies to enable widespread adaptation. And we'll talk about some of the hydrogen hubs in the next slides. And then finally, we look at collaboration. There is a lot of collaboration going on right now. So obviously we have collaboration through sites like these, where I'm sure this is not the only presentation that will be discussing hydrogen, but there are various different industry groups. Governments are heavily invested, academia, research institutions, all to foster partnership and knowledge sharing to initiatives aimed to accelerate the progress and overcome any type of technical issues or market barriers to further the hydrogen economy. Some of the plans that we currently have within the country in order to regionalize the use of hydrogen is focusing on these hubs. Currently, there are about 17 hubs, which are either various different consortiations through public and private conglomerates that are getting together and in between multiple different states, where they're looking to develop the infrastructure either for hydrogen storage, hydrogen utilization, any type of transportation systems associated with that. When we compare that overlay to the grid of the national electrical grids that we see here, that you see that most of these hubs fall within those grids, and then also the overlay on the side, you can see where hydrogen generation stations are in relation to where renewable energies lie. A lot of this has to look at the availability and on how it interacts with not only the markets that you're in, but also with the renewable grid. So when we look at the electric grids, there are some considerations to look at. We need to look at supply and demand fluctuations, that we don't want too much renewables in one area, because if the wind's not blowing, then we might not be able to get certain supply within that. For instance, if you're heavily invested in wind turbine technologies, we saw some of that in Texas when we had that cold freeze event, and a lot of the wind turbines went offline, and they had issues, with providing electricity, to the public. Other ways to, look at necessitating the electrical grid are with frequency regulation. In this country, we are at 60 hertz, and we can regulate plus or minus 1% of that target frequency. And then also capacitor banks, which can also help with load sharing. What hydrogen does bring in with renewables is that those times that we do have an excess demand of electricity, as opposed to either bleeding that electricity off through either banks of resistors and generating heat and then have it dissipated, or to open gates, if you will, to put that electricity in other regions. We can go ahead and facilitate the production of hydrogen and then keep that in either gaseous or liquid form, or store it for needs of time that you have low base load. So it does provide the ability for renewables to have base load following capabilities on times when you have low utilization. You can produce hydrogen, and then when you're not producing electricity, that hydrogen can be used to produce electricity to further supplement the grid. This overlay as well does show you where all the available pipelines in the United States are, and then also where all the hydrogen production units currently are. Predominantly, a good majority of hydrogen production currently is through steam methane reforming. So you can see that's heavily used on the Gulf Coast. Just to give you an idea, there's only 1,600 miles of hydrogen piping, and most of that is within Texas and Louisiana. So as you look at Texas and Louisiana and you see those black lines, that is the 1,600 miles of piping. Now, there have been studies that show, due to the issues that you might have with hydrogen embrittlement on piping, hydrogen does have special piping considerations, so it's not as easy to just switch over from natural gas and then put hydrogen in there, because you could have issues later on down the lines with the structural integrity of the piping or potential hydrogen leaks. So some of the hydrogen solutions that we are going to be providing, again, as we said, we're the world's largest AIA, so we do have experienced inspectors that not only looked at the ASME, but also look at other standards and pressure vessel equipment, and also deal with power generation. So this is something that we have been looking at, and then we are looking at currently right now. We have multiple clients that are within the hydrogen sector. From the ASME side, the production of pressure vessels have application and use for hydrogen. Same thing with transportation vessels on DOT, where our engineers have looked at those either with an inspection or design review verification. HSB role in the carbon neutral environment is in its role for global energy transition to a carbon neutral climate. The hydrogen management requires changing of equipment and handling that can be accomplished with new designs, equipment, and processes. And we can provide a suite of solutions to deliver supply chain, expediting conformity assessment, quality assurance, qualification surveillance, risk mitigation, and ensuring safety and efficiency for your products. Hydrogen gains prominence in the world energy transition through the design of the equipment, can become critical for safety and efficiency and reliability. There are several key considerations to take into account when designing hydrogen equipment that meets requirements in the emerging industry. Also, you need to take into consideration the permitting process as well. Unlike most projects that we deal with pressure vessels, you do have state regulations and jurisdictions. Most of these permitting processes could go down to the municipality itself. In the latest census, the U.S. government identified that there were over 90,000 independent municipalities across the United States. All right, so it's not necessarily that we're going to have 90,000 ways of possibly providing information to that. So we're looking to come up with a solution to come up with a set of standards to develop to where you have some type of uniformity within the requirements of what people are looking at for permitting. Also, you also have considerations with material compatibility. As I said, that hydrogen does cause different effects, predominantly embrittlement due to the size that it has a small molecular mass, and you have potential of corrosion, instability, and pressure intolerances. Safety measures as well. Hydrogen is flammable. Also, you need to take into consideration leak detection, contamination systems, and ventilation. Performance and efficiency. Again, these are looking at heavy investments, so making sure that your plan is optimized and it's performing as it should. Scalability and flexibility for hydrogen technologies as a rapidly evolving equipment design should account for the scalability and the adoption for future advancements. So this could be that you might have one or two electrolyzers on site, and then you further expand that down to multiple electrolyzers as you increase the capacity as you're producing hydrogen. And then finally, the regulatory compliance does become an issue because we find that this is such new emerging technology that a lot of the permitting boards really don't know what standards should be used and how to use them properly. You know, a lot of people don't understand that if you're dealing with a pressurized vessel, that needs to conform to Section 8 ASME requirements in many aspects, as you have in many jurisdictions. So there are a couple of you know, established manufacturers within the industry, but we're seeing a lot of new people coming to the field wanting to be part of this industry as well. And regulatory compliance is a struggle for a lot of people, you know, to make sure that they've designed something according to an applicable industry standard and understanding what the risks and mitigations are for that. Another aspect that we do is with our supply chain expediting. We would communicate with suppliers and vendors. We can maintain a regular communication with suppliers and vendors to ensure that they understand the contractual requirements and the specifications. This communication can help establish clear lines of communication, resolve any potential issues, and keep everyone in line with delivery and expectations. Cost overruns do become a big issue if you know, lines of communication aren't there. Also look at the monitoring and tracking deliverables and deliveries. HSB can actively monitor and track the delivery progress of materials, components throughout the supply chain. This involves regularly checking with suppliers and logistic providers to verify the status shipments and identify potential delays or issues. We could also coordinate proactively if any issues do come up between you and your supply chain to alleviate any type of technical code concerns or regulatory concerns for the timeliness of delivery. Within scheduling coordination, HSB can coordinate and schedule meetings with vendors, suppliers to discuss progress from a project management perspective and address any concerns that ensure that everybody's on the same page. Also, verifying vendor inventory and processes. We could perform audits, inspect, and verify monitoring inventory and processes includes checking that the supplied materials and components meet specified standards, either through a receipt inspection or a final inspection closeout on the site. And then also identify and mitigate any supply chain risks. Again, proactively develop strategies, whether it's involved with the supplier's capabilities, evaluating alternative sourcing options, or implementing contingency plans, or monitoring internal factors that can impact the supply chain, such as geopolitical events or natural disasters. Conformity assessment. In this case, one of the issues that we do see that is affecting the hydrogen industry as a whole is that there are all kinds of standards out there. None of these standards are predominantly called out by either the federal level or the state level as necessary, other than the fact of pressure equipment. So HSB has developed a set of inspection test plans that are developed based off of known industry standards that they are tailor fit with our clients in order to make sure that things are inspected not only to applicable standards, but also to the design spec or the customer requirements and the specifications needed. We also perform third-party inspections to conduct independent reviews of to applicable standards of your supply chain or within yourself as well, to make sure that we ensure the highest levels of quality and safety. Also, within testing and evaluation of hydrogen storage and transport systems, this follows very similar to ASME Section 8, witnessing pressure tests. We do verify that those tests are complete, conducted on components, systems, subsystems, and verify compliance with technical standards and regulatory requirements. We also evaluate code compliance of hydrogen-powered equipment and vehicles for experts to assess code compliance with such equipment. We have the capability, and we are currently reviewing hydrogen designs for pressure components, verifying that the proper material, proper configuration to operate accordingly for the proper structural integrity and manufacturing processes are complete. Verify compliance with the industry standards and regulations. Our experts can go ahead and make sure that we are meeting the appropriate standards, not only within your jurisdiction or within the country that you operate through our global engineering force, that we can make sure that that comes in line. For in-service processing, we can look at continuously monitoring a process as your equipment's getting fabricated. And then we can also provide training and education on conformity assessment for best practices. And in the end, we can also provide third-party certification and audits based off of the deliverables or activities that are performed. Now, this does have a lot of weight, especially when you have third-party investors that are receiving notice that you have these certificates of a third-party inspection performed by Hartford Steam Boiler. Again, we are trusted, noted within the industry, and that can give them that extra level of assurance to alleviate any type of, to mitigate any type of investment risk or within the permitting process, knowing that there is a third party doing those inspections that are within the field based off of our trust and credibility within the marketplace. We also do offer quality management systems. We are, are an ISO registrar service, looking at ISO 9001, which is looking at for your quality management systems, for your quality manual, also your environmental manual and occupational safety. So this is a service that Hartford has been doing for many, many, many years, and we do have a lot of clients and a lot of experience doing this. Within our vendor qualifications, as I stated, we do look at our hydrogen solutions inspectors. As I said, they're located globally and can provide vendor qualification service on your behalf by evaluating and approving vendor supply materials and components for your hydrogen products. This process can also include a comprehensive evaluation of your vendors' facilities, equipment, processes, and personnel to ensure that they meet the required standards, regulations, and safety, quality, and environmental impact. And the goal for this is essentially to help you qualify your supply chain. And this is something that we've done on the commercial and nuclear side. Again, just to give you some examples, we can review the vendor's safety records and compliance history. We can inspect the vendor's facilities and equipment, as I just said, assess the vendor's production processes and quality control measures, evaluate the vendor's personnel training programs, making sure that their people that perform specialized activities such as NDE and welding are properly qualified and meeting industry standards, and then also review the vendor's environmental impact and sustainability practices as they are qualified to either various different ISO standards for those environmental considerations. Vendor surveillance does offer slightly different than what we say. In this case, we would do regular inspections to the vendor facilities. We can monitor the manufacturing processes as they're currently occurring. Witness material and component testing. Again, this is going to be within the shop as your representative to witness some of these critical hold points that you might identify. Also verify material receiving, traceability, and storage, and then also have audits of vendor documentation and quality records to make sure that we have accuracy and quality throughout the whole entire process. Risk mitigation is another aspect that we do. In this case, as I said, depending on how you want to look at to further alleviate any type of risk within your supply chain, we would, in this case, conduct regular inspections and audits at the vendor sites, to perform inspections and audits at vendor locations to identify any type of potential risks, deviations, or non-compliance of quality or safety standards. And we also look and verify that the vendor's quality system implementations are established to minimize any type of rework. We also suggest best practices within the supply chain to eliminate and minimize potential delay. witness material testing to verify proper material traceability. In this case, we would go ahead and look at material testing conducted by vendors to ensure compliance with standard requirements, whether it's going to be to a component specification or material specification. We would have that third-party oversight for that. Verify vendor implementation for contractual requirements, quality procedures, safety procedures, and industry standards. Again, this could be pretty big issue if you have a component that's built across several different shops that all have to come together in succession in order to produce the product in a timely manner. And then also, again, continuous monitoring and evaluation for performance of implementing HSB Hydrogen Solutions with the monitoring in place if need be, if you choose that route of service. Our design verification is also highly used. In this case, we do provide a third-party independent review on equipment design. We have staff within the United States and over in India that do calculations, look at your design. Currently, I think right now we are reviewing 3 or 4 hydrogen transport vessels for various different clients. And this is something that we do on a regular basis. We identify areas of concerns that might need additional in-process testing during fabrication, identifying these special requirements for materials based on the type of equipment. And as you know, hydrogen does have very specific material requirements that are out there. Review and specify and verify the design of hydrogen pressure components. The engineer can specifically review and verify design hydrogen components involved in assessing the structural integrity, material selection, well design, other critical aspects to ensure compliance with industry standards. Verifying compliance with industry standards and regulations. Again, if we choose a specific code or if we need to meet certain regulatory aspects, whether it's part of the jurisdiction, we can go ahead and validate that that has been completed. And then also we can provide training and education on design verification and best practices to your engineering staff. So what I've talked about so far is just one aspect that HSB as a whole does with that. We have been known as a equipment breakdown insurance company, but we also are developing further products to facilitate the hydrogen industry. Such as we look at insurance for equipment breakdown, we have discussed and are looking to provide performance guarantees. So as we are providing this certification that we stand behind, we will also stand behind the performance of the amount of energy or the amount of hydrogen that's produced as it's built and as it's inspected. And that does provide a lot of relief for any type of financial backing to have those guarantees in place. And this is a product that we're further developing. We also talked about in-service inspections. You know, it's not so much that you do the inspections while this item's getting constructed and then upon commissioning, you never look at it again. We will provide those in-service inspections, which can go back to some of our other insurance products in order to ensure the overall facility. Safety monitoring. Safety monitoring, we can do that through remote sensors to, monitoring your system, whether you have low levels of coolant, if you have a cryogenic system, or if you have any potential hydrogen leaks. That is something that we can have in place to actively provide that extra layer of protection and constant monitoring. And then also cyber. Since cyber has been a concern within the last few years, HSB does have capabilities for ensuring cyber. So with that, this QR code, you can go ahead and take a picture on your screen and it will go back to HSB to provide more of an outlook of some of the products that we discussed today and an overview of the hydrogen infrastructure of the hydrogen economy and how it's developing. So, with a quick recap with HSB Hydrogen Solutions, you can see that we foster a lot of different avenues for our clients that if we do work with you on doing that, we can provide various different oversights to your processes to ensure that you have you're able to meet any type of production deadlines, that you have a certification from a known industry leader within the field that can be used in order to further help within your permitting process or within alleviating any type of financial risks or safety risks that are associated with that, and we stand behind the work that we do within that. So at this time, I will open it up to any questions.
All right. Thanks, Paul, for that great presentation. And to the audience, we're going to move into the Q&A session in a moment. If you haven't submitted your question yet, you can still do that by entering it in the Q&A box on your screen and clicking submit. Or if you have a comment, we would love to hear from you. We're going to try to get to everybody's questions today. However, if we don't get to your question for whatever reason, we will reach out after the webinar is over. So please send us your questions. Okay, and now for our first question from the audience. What are some potential barriers to the adoption of hydrogen technologies in the U.S.? Paul?
All right, so this is something kind of the good question, something that I do look at on, showing to a lot of people on, what are the concerns and how viable is hydrogen? So, off the top of my head, there's a couple things, and some of the things that I have mentioned here. So we look at the cost. What is the associated cost when you're developing a new technology? There's kind of a barrier to that transition for fossil fuels, to a new method of energy. This is something that if we look at the electric vehicles 10, 15 years ago, electric vehicles were only used in very specific areas of the country. Now they're widespreadly used because they've adapted and built the infrastructure out to support electric vehicles. Same thing we're looking at with hydrogen to reduce that cost. We're looking at utilization within the hubs to further develop the infrastructure, which is currently not there, but it's currently building. And then also transition some of the existing hydrogen capacity to be more of, carbon neutral, with that. We also look at, transportation and storage. Again, hydrogen's kind of, one of those, gases that, because it has a low molecular density, it does affect material properties in certain different ways. So making sure that we can transport that efficiently, whether it's gas or whether it's high pressure or whether it's in a liquid form. And now you're talking about cryogenics. That does become considerations. There are new materials that they're looking at, which are hydrides, which can absorb the hydrogen, which could have it be a little safer for transportation, but that area for hydrides is still within development. Obviously, there's the safety concerns. All right, everyone thinks of hydrogen, they think of the Hindenburg. Obviously, it's not a one-for-one comparison with that because the Hindenburg had other issues going on with that. But, one of the positive things about hydrogen is that hydrogen is a low-density gas and will just go up in the air. So if you do have any type of leaks, you just need to make sure you have proper ventilation and reduce the risk of flame as opposed to a gasoline fire where it just basically hovers over the surface and you have a continuing flame. So we need to understand that. We need to understand, the lack of familiarity with the hydrogen because it is something new. I'm sure a lot of you guys didn't know at the beginning of this presentation the widespread use of hydrogen for the last 100 years. Also, I'd like to add that electrolysis isn't something new. We've been using electrolysis, or at least alkaline electrolysis, for almost 100 years. And it was the primary way that we've made hydrogen up until about the 70s or 80s, to where we adopted steam method reforming, and that became the predominant way to, produce hydrogen. So there is that lack of awareness, and that familiarity with it. Again, competing technologies, how do we compete with fossil fuels, make it affordable, make it reasonable, as opposed to just saying green? We need to make sure that it makes financial sense. And then, and I kind of hit on it before, but the policy and regulatory framework, really there's, DOE's got some guidance out there. Some of the national labs have produced some guidance, but then when it leads to the decision makers, a lot of them really don't know what they're looking at, especially from the permitting process. We might have something that comes up from Europe and it's built to the PED and not realizing that it needs to meet ASME Section 8, because it's a pressure vessel before it gets installed. So there are, kind of a gap within the policy and the regulatory framework, since there is a lot of things out there not knowing what exactly we can use. This is a good question. Thanks.
Absolutely, yeah, and thank you for that answer. To the audience, we are in the Q&A session. You can still send us your questions. We have our expert Paul online, ready to provide you with answers. And while you're thinking of your questions, I just want to take a moment to point out on your screen, in the top right corner, you can access the website. And there's also a contact us email that's also displayed on the slide, but you can click on it on your screen in the resource list. And we definitely encourage you to reach out to the team if you have more questions or just want to start a conversation. All right, back to our questions. Wow, a lot of great questions in the queue. Like I mentioned, we'll try to get to everything, but if we don't, we will reach out later. Here is our next question from the audience. Do you perform fault tree analysis for risk mitigation?
Yeah, so our analysis is fault tree analysis for risk mitigation would be heavily involved, based off the understanding of the design that you have, with that analysis and developing any type of potential risk assessment models, which might go into developing, either some type of insurance product or identifying potential issues that, might be inherent within the design that we would make the client aware of. So we do facilitate it. We don't. I don't believe that that's something that we normally do, but within the fault tree analysis, that would be something that we would be involved in, working with your design engineers accordingly to make sure that you do have a design from a deterministic, effect, either meets some type of prescribed code or standard. We do not do problematic risk assessment per se, with that, but we do rely heavily on making sure that your design meets acceptable established codes and any type of guidance that might be put out by the jurisdictional authorities.
That's great. Sounds like a lot of support coming from the HSB team. Wonderful. And great question. Okay, moving on to our next question. Are power transformers included in your scope of expertise?
So technically, Hartford Steam Boiler is known as equipment breakdown. Power transformers within our specific group are not included, but we do have the capability to look at those components based off of other expertise within our company as a part of the full HSB Hydrogen Solutions. We would have to look at, with our clients directly at the scope of, what's needed to be looked at, and then we can assess there, how we would address it and how we be able to service our clients.
Excellent. Thank you for that. Okay, moving along to our next question. At what temperature and pressure do you start using ASME Section 8?
Yes, so ASME Section 8, I do believe that, at the beginning, I believe it's in U2, it does talk about temperature and pressures that you can use it. Anything above 15 pounds gauge pressure is where you would go ahead and use, or ASME Section 8 would be applicable. I know for most of the designs that I've seen that they are operating at about 700 bars. So they are, high pressure systems to use that. In most cases, I would say that if you look at your standard PEM electrolyzer, that the casing within itself would fall under the prospects of Section 8. In fact, Section 8 is looking at further developing the guidance either within the code or a code case to specifically address electrolyzers, which currently aren't, but because they are in a pressure vessel, the expectation for most of the jurisdictions are that it does meet Section 8 within the United States. And I know over in Europe, they are built to the PED code.
Excellent. Thank you for that. Okay, to the audience, we're still in the Q&A session. You can still send your questions in. You can do that by adding that information to the Q&A box on your screen and clicking submit. I just want to take a moment to address a few thank yous that we received. I want to pass those over to Paul. Thank you very much for that great presentation again. And there's a few questions asking about the replay. Yes, this entire webinar and the Q&A session that we're currently in right now will be available as a replay on the Global Spec site for the next 90 days, so you can come back and watch this again. Okay, let's get back to the questions. And here's our next question from the audience. Since there are numerous standards at this moment for hydrogen and its related fields, What will it take to combine and/or reduce standards to cover this field without compromising safety?
Thank you for that question. That's a question that I look at to answer all the time within the field of what we're looking at. And really, there are three different sets of standards that we look at. We look at kind of the I'm not going to go into the differences between a code and a standard. Generally, a standard is something that's produced, and then a code would be a standard that gets adopted by a jurisdiction. So we have a lot of the jurisdictions that have very generic either building, electrical, and fire codes, which basically address that and go into more specific within industry codes or component codes. So I think what the big disconnect is that you have a lot of codes out there which are either component codes or industry codes, which might rely off of one another, but they might not be properly captured within the a city's building code or electrical code that they use. NFPA2 is predominantly the main one that people use as an industry code for hydrogen. And then that does reference some other component standards. I've thrown out Section 8 a lot. That's obviously your component standards for vessels, but you have SAE specs depending on, whether you're looking at some type of fuel nozzle, if you will, or if you're talking about transportation, aspects. And then you have the CGA standard, which talks about any type of hydrogen type relief standards on there. The thing is that I can go onto the DOE website right now and I can see a laundry list of standards, but that does nothing for me unless I know how to apply them applicably for the application that I'm using in order to meet jurisdictional requirements and to ensure that we have developed our designs based off of that, along with a inspection scheme or a test plan that follows those standards to show that we are producing, safe quality components to be installed within these facilities. So again, I think it's kind of the harmonization of all these standards out there, depending on what flavor you're using, whether it's going to be ISO in nature, because ISO has thousands of standards, whether you want to go the ASME route, and then how it interacts within that specific jurisdiction that you're operating in. You might have an off-the-shelf design, which is perfect for installation in California, and then if you try to install that design in Germany, you might have to completely redesign it to a very different set of standards.
Very interesting. Great question. Okay, let's see what we have left. All right, looks like we have a few more questions in the queue at this time, so we're going to get to those in a moment. But if anyone has any last questions or comments, please send them in by typing them in the Q&A box and clicking submit. Okay, here's our next question. It appears that railcar transportation of 1,000 bar gas is viable, but I have not seen much in this area compared to the promotion of liquid forms for transportation. Does HSB see railcar transportation of gas as a potential player in the H2 distribution network going forward?
Well, I think railcar transportation of the liquid gas. So again, I'm assuming we're talking about cryogenic storage. And just to throw some numbers off the top of my head, I don't have the reference in front of me. I believe you liquefy hydrogen at about negative 420 degrees Fahrenheit, give or take a couple degrees. I might be slightly off on that, but that's really cold, and that takes a lot of energy to keep something within that temperature when we're looking at cryogenic tanks, and those also have their own set of challenges with that. So I can't tell you from a cost savings perspective if liquid storage would be feasible as opposed to a gaseous storage medium, or perhaps using the advanced material storages that I talked about. I think the economics of that will work its way out on what's fundamentally feasible. But I do see rail transportation as probably being the predominant source of getting hydrogen out there, because if you saw from one of my slides where I talk about where all the hydrogen infrastructure is and the pipeline that's currently associated, we only have 1,600 miles of pipeline, all right? So within these hubs themselves, you're either gonna have to produce the hydrogen on site through a scalable electrolysis, or you would have to do some type of transportation. If you look at one of the well-established hubs in Los Angeles, right? I can go ahead at any time, look at all the different hydrogen refueling gas stations out there, how much hydrogen they have on hand, and whether they get that hydrogen and store it either in liquid or gaseous form, and and how it's delivered, whether it's delivered by truck or whether they have some type of gas line per se, or whether they do it on site. So I think in the interim, short of either converting pipelines or rebuilding a pipeline network, I think rail is going to be the most logical way, or either by truck currently to transport hydrogen back and forth until these hubs really start taking off, and then it's more feasible within that geographic location within the hub to come up with the transportation scheme for hydrogen. I think that's where we're going to see, again, the type of transport they're going to do, whether it's going to be storage based off of cryogenic storage or a high pressure storage medium, and what makes sense financially within that area.
Excellent. Thank you, Paul. Okay, let's see. Looks like we have a couple questions. We're going to get to those in a moment. But to the audience, if you have anything left, please send it in now. We'll try to get to it. And again, if we didn't get to your question, we will reach out later. Okay, here is our next question. How can hydrogen be integrated into the existing energy system, particularly in terms of grid balancing and storage?
So thank you for that question. So I do believe that the term that people are looking for integration within the existing energy system is the power to gas technology. In this case, when we look at renewable energies where they're at, whether it's wind, or solar, hydro it's kind of its own separate animal, but we're looking at these potential renewables that could be intermittent in nature, meaning that the wind doesn't always blow and the sun doesn't always shine. But when it does, we do have the possibility of creating, excess electricity at that point. And then instead of bleeding off that electricity, we can convert that power to gas through using a process of electrolysis, which is those electrolyzers that we have on site. And then through fuel cells, we can go ahead and run hydrogen through there, and that in itself can produce electricity. So the key is having a, using the renewable energies that are not necessarily completely reliable 100% of the time, and making them reliable to have a load following capability to supplement with excess or hydrogen that's produced during the excess power times. So that's how we could see a lot of that get integrated into the existing infrastructure as well. Other than that, I could see that a lot of the utilization for this will not be at a large industrial level, but within microgrids. And again, I'll refer back to the hubs that we have in place. I would say it's not before long that we will eliminate deliveries to hydrogen refueling stations and just have electrolyzers there that are making hydrogen on site, which will further decrease the cost, because now you don't have a transportation and delivery cost associated with the hydrogen as well.
Wow, cool stuff. Very good. Okay, looking at the queue, looks like we have one last question right now. So we're going to get to that in a moment. But again, to the audience, now would probably be your last chance to send anything in. So if you have anything left, please send it in. But for now, here is, and here is our next question. Oh, sorry, 1 second, just lost my, oh, here is our next question. Apologies, audience. How can HSB inspection and engineering services help the client navigate this growing focus on hydrogen?
Right, so, I kind of went over it in my recap, but, just go a little bit more in detail, or just to reaffirm what we said. We're approaching this from a risk assessment mitigation. Again, we had that question before, and the way that we do this, we're going to identify risks and potential safety hazards associated with hydrogen technology by evaluating, various different stages from the hydrogen production, storage, transportation usage, and usage of hydrogen, and variables developed for the appropriate risk strategies. So again, this is going back to a deterministic approach using industry-known standards that will ensure the safety as these items are produced and used accordingly. Also, with that goes into the compliance of codes and standards. There is a code and standard out there. You might not know or might not be apparent how it's harmonized, but they do provide a basis of how the industry should operate and what the industry should do for further developing the hydrogen infrastructure out there. Equipment inspection and testing, material selection and assessment, training and education, and then also within our insurance products, insurance does provide some type of risk management for insurance providers and specialty risk, whether we attach some type of sensors for leakage detection, or whether we evaluate the design and come up with an associated risk factor. So these are some of the the aspects that we could use in order to do that, along with on-site inspections, verifications, surveillances, the whole slew of things. So we're taking a traditional conformity assessment process and enveloping it within your program, to further ensure the safety and the reliability of your product.
Excellent. Thank you for that. Okay, looks like we have a couple more questions in the queue, so we're going to get to those in a moment. But I just want to mention again, on your screen, there is some contact information to reach out to the team. We do encourage you to do that. Okay, here's our next question. Generation of hydrogen by electrolysis often occurs at low pressures, close to atmospheric pressure, but for use in ammonia or methanol plants, much higher pressures are required via compression. Have you seen providers of hydrogen packages offer or have flexible offers to supply hydrogen at much higher pressures as package units for such applications?
Yes, so I would have to go back to some of the design specs that I have looked at before, but I do believe that alkaline electrolysis happens at significantly lower pressures, and a lot of the newer technologies, such as the proton membranes or the PMs, do operate at higher pressures. Again, I keep on 700 bars keeps on coming to mind, but I would have to look at the design spec right in front of me. I know like a lot of them do have compressors to either further move the gases or to further compress the gases, as need be for their various different applications. Like I said, there's multiple different designs out there. So, I would have to look at a specific design for that. But my understanding is that the new type of electrolyzers, which are being heavily invested, do operate at significantly higher pressures than atmospheric.
Excellent. Thank you for that. And great question. Okay, looks like we have time for one last question, and here it is. With in-service inspection in mind, hydrogen generating plants have cold boxes that have many pressure vessels in place inside that are under vacuum. How does HSB put together an inspection process for recurring inspections on these types of objects that they cannot put eyes on?
That's a really good question. There are a lot of situations where you have components that are enclosed, but there are telltale signs that when you look at the operation of a facility, that if we are tracking, various different attributes within its operation, such as pressure, temperature, perhaps vibrations, that any of our sensors can pick up, you can develop a profile on the normal operation of the equipment. And whether it's through interface or whether it's through AI or whether it's through, detailed inspection of reports, you can actually see slight fluctuations within those operating characteristics, which might be symptoms of something else going on, with that. It's kind of like when you go to the doctor, on the outside, might look that you're fine, but when you do a detailed look on the inside, there are, you might find that you have cancer or leukemia, which might not be apparent by looking at you. In this case, the doctor doesn't have to cut you open to see that, but they are diagnostic testings that you could do. So we can use a variety of NDE, a variety of different assessing different operational characteristics to assess if there is a potential problem internally that we can't look at. So it's not so much as having an inspector just looking around and maybe with a hydrogen sniffer seeing if there's any type of leaks. But as these systems are monitored, you could have a good detailed understanding of what's going on inside for areas that you can't look at. And again, that's all going to be specific to the design and the applications that they're being used for.
Excellent. Thank you for that. Okay, and that was our last question for today, so we are going to wrap things up right there. So once again, Paul, thank you so much for that great presentation and also taking the time to answer some questions. And of course, we'd like to thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation. So as mentioned, you can come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.